Good morning, students. After the completion of the chapter Chemical Kinetics, next we switch over to the second chapter of Physical Chemistry, that is Electrochemistry. It is a very important one for exam point of view. So today in the first class of the Electrochemistry, I will try to complete introduction, what is electrochemistry, what is electrolyte, non-electrolyte, weak electrolyte, strong electrolyte, what is electrolysis, the process of electrolysis, then preferential discharge theory, and some problems, that is application of preferential discharge theory. Let us discuss one by one. First is definition. What do we mean by electrochemistry? First we discuss the chapter today, that is electrochemistry. First is definition. What do we mean by electrochemistry? It is a branch of chemistry which deals with the study of a relationship between chemical energy and electrical energy. I repeat again. It is a branch of chemistry which deals with the study of relationship between chemical energy and electrical energy and interrelation with it. I repeat again. It is defined as the branch of chemistry which deals with the study of relationship between chemical energy and electrical energy and the relationship and the interconversion between them. I repeat again. It is defined as the branch of chemistry which deals with the study of relationship between chemical energy and electrical energy and interrelationship between them. That means this electrochemistry gives an idea about the relation between two terms. One is the chemical changes takes place by the passage of electricity, and it is carried out in a device which is known as electrolytic cell. And second one, the production of electricity as a result of redox reaction, and it is carried out in a device that is known as electrochemical cell or galvanic cell. So the total electrochemistry is divided into two subgroups. One is electrolytic cell and one is galvanic cell or electrochemical cell. I repeat again. This chapter, that is electrochemistry, provides us a relationship between, point one, the chemical changes taking place as a result of passing of electric current, and it is carried out in a device known as, point one is electrolytic cell, and point one, the production of electricity due to the redox reaction, and it is carried out in a device known as electrochemical cell or galvanic cell. Second one is electrochemical cell or galvanic cell. So first we focus to what is electrolytic cell. basing upon the conductivity of electricity, whether that substance allow electric current or not. Basing upon this, the substances are classified into two categories. One is metallic, one is electrolyte, one is non-electrolyte. One is conductor, one is non-conductor. Mark that. I repeat again. On the basis of conductivity, substances are classified into two types. One is conductor and one is non-conductor or insulator. That means the substance which allow electric current to pass through it, known as conductor. The substance which does not allow, it is known as non-conductor. Again, conductor are of two types. Mark that. This conductor are of two types. One is known as metallic conductor, one is known as metallic conductor, and one is known as electrolyte. On the basis of conductivity, conductor again is of two types. One is known as metallic conductor and one is known as electrolyte. First is metallic conductor. That is the metal through which electric current pass easily. The metal through which electric current pass easily without any change in chemical property, without any change in mass or change in chemical property is known as metallic conductor. And here the free electron plays a significant role for carrying electricity. And one important thing is that on increasing temperature, the conductivity in metal or metallic conductor gradually decreases. For example, iron, cobalt, nickel, these are known as metallic conductor. On the other hand, electrolyte, what is electrolyte? The substance through which electric current pass easily with a change in mass, with a change in concentration, then that is known as electrolyte. Here, free ion play an important role for conducting electricity. And most important thing is that on increasing temperature, conductivity of the electrolyte increases. Again, electrolyte is of two types. One is strong electrolyte, one is weak electrolyte. Mark that. Electrolyte is again of two types. One is strong electrolyte, one is weak electrolyte. Mark that. What do you mean by strong electrolyte? The electrolyte which is completely ionized in aqueous solution and possesses highest conductivity known as strong electrolyte. In this case, the degree of dissociation, degree of ionization, that is alpha, is equal to 1. That is, example is strong acid, strong bases, salt solution. I repeat again. Strong electrolyte are the electrolyte which are completely ionized in aqueous solution and possess maximum conductivity. Here, alpha, that is degree of dissociation, degree of ionization, is equal to 1. On the other hand, weak electrolyte, these are the electrolyte which is partially ionized, weakly ionized, and possess minimum number of ions and possess lower conductivity, that is known as weak electrolyte. That is weak acid, weak bases are comes under weak electrolyte. Then we discuss about another one term, degree of ionization or degree of dissociation. What do you mean by next term is degree of ionization. Symbol is alpha. What do you mean by degree of ionization? That is the fraction of molecule dissociated into ion is known as degree of ionization or degree of dissociation. That is, it is alpha is equal to fraction of molecules dissociated into ions divided by total number of molecules present in the solution. That is degree of ionization, that is a fraction of molecule dissociated divided by total number of molecules present in the solution. In case of strong electrolyte, alpha is equal to 1. In case of weak electrolyte, alpha is less than 1. So mark that another relation also there. That is alpha is equal to, I repeat again, alpha is equal to 1 in case of strong electrolyte, and alpha less than 1 in case of weak electrolyte. And another relation is there, alpha is equal to Ka by C root over, or H plus ion is equal to Ka dot C root over. Mark that. Here Ka is known as the degree of dissociation, degree of ionization constant for an acid, and the C is known as concentration. H plus ion is the strength, that means acid ion constant. To calculate the H plus ion constant, what is the percentage of acidic strength in the solution for an acid? Similarly for a base, if we calculate for a base, that is alpha is equal to Kb by C root over, or OH minus ion concentration is equal to Kb dot C root over. Here also Kb known as degree of ionization or degree of dissociation for base. Next we discuss another term, that is electrolysis. Next one is electrolysis. What do you mean by electrolysis? The process of decomposition of an electrolyte by the passage of electricity is known as electrolysis. I repeat again. The process of decomposition of an electrolyte, the process of decomposition of an electrolyte by the passage of electricity is known as electrolysis. The process of decomposition of an electrolyte by the passage of electricity is known as electrolysis. It is carried out in a tank known as electrolytic tank, which is made up of wood, glass or cement, in which fused or aqueous solution of solid taken, which is known as electrolyte, two metallic rods suspended into it, which are known as electrode, one connected to the positive terminal of battery while another connected to the negative terminal of battery. That one connected to the negative terminal of battery known as cathode, while that one connected to positive terminal of battery known as anode. So during electrolysis, cation goes to cathode, get deposited. Cation goes to cathode, gains electron and get deposited, known as a primary change, or it may undergo some secondary changes to form another substance. Similarly, anion moves towards anode, lose electron and becomes atom, remain as such, that is known as a primary change, or undergo some secondary changes to form another substances. Mark that. When an electrolyte, what is the process? Next we discuss what is the process of electrolysis. Next we discuss the process of electrolysis. Process of electrolysis. Mark that. The container, it is a container made up of wood, glass or cement, that is known as electrolytic cell. When two metallic rod is there suspended, which is connected to, one is cathode, connected to the negative terminal of battery, one is known as anode, connected to the positive terminal of battery. This is known as salt solution, fused or aqueous solution. It is known as electrolyte. Mark that. When electrolyte dissolve in water, it is break down into ion, cation and anion, which are moving rapid random throughout the different direction in the container. But when we apply electric current, cation moves towards cathode, gains electron and get deposited, that is known as a primary change, or some undergo some secondary change to form different product. Similarly, anion moves towards anode, that is lose electron and remain as such, that is known as a primary change, or they also undergo some secondary changes to form the different product. Most one important thing is that if during electrolysis more than two type of ions are there, so here we discuss that is a cation moves towards cathode, anion moves towards anode. Two type of ion is there, one is positive ion, one is a negative ion. So if more than two type of ions are there, then it has been observed that all of them are not discharged, all of them are not migrate to their respective electrode. Then how we decide which ion moves to their respective electrode? It is verified by a theory known as preferential discharge theory. Next we discuss about preferential discharge theory. Preferential discharge theory. This theory states that if more than one similar type of ions are present during electrolysis in electrolyte, then that ion moves toward their respective electrode, which possess least chemical energy or more deposition potential. I repeat again. During electrolysis, if more than one similar type of ions are present, then that ion will migrate to their respective electrode, which possess least chemical energy or more deposition potential. Least chemical energy means that one possesses less discharge potential and more deposition potential. In other words, this theory may also be said that if more than one similar type of ions are present during electrolysis, then the cation, which are stronger oxidizing agent, get preferred to deposit at their cathode. Similarly, that anion, which are stronger reducing agent, get preferred to deposit the respective electron. I repeat again, this theory states that if more than one type of ions, if more than one type of similar ions are present during electrolysis, then the cation which is strong or stronger oxidizing agent get preferred to deposit at cathode. Similarly, for anions, that one possesses stronger reducing agent get preferred at the anode. So which one possesses stronger oxidizing agent? Which one possesses stronger reducing agent? Whose deposition potential is high? Whose deposition potential is low? How we know? That is, these are arranged in an increasing order of deposition potential, increasing order of deposition tendency in a series that is known as activity series. Two series are there. One is for a cation, one is for anion. That is, we have to arrange the increasing order of deposition potential, increasing order of deposition tendency, one for cation and another for anion. First we discuss for cation, next we discuss for anion. So first for cations, the series is potassium, calcium, sodium, magnesium, aluminium, zinc, iron, that is potassium, calcium, sodium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, next is silver, last one is gold. Mark that it is increasing order of deposition potential for cation. Next, similarly for anions. This one for increasing order of deposition potential for cation. Next we discuss for anion, that is sulfate, nitrate, hydroxide, chloride, bromide, iodide. That is, it is also increasing order of deposition potential. Next, we discuss some application of preferential discharge theory. That means we discuss some numerical part, application part. If more than one electrolyte is there, which one migrate to their respective electrode, means among the two cation, which one move to their cathode, and among the two anion, which anode, which one move to their respective anode. We discuss some problems one by one. First one is electrolysis of molten sodium chloride by using platinum electrode. Electrolysis of molten sodium chloride by using platinum electrode. Mark that. So before going to this one, another important thing is that we have to remember, along with the preferential discharge theory, so another one point also there, which ion migrate to their respective electrode. It also depends upon the concentration of the electrolyte and also nature of the electrode, whether it is attackable or non-attackable. We discuss one by one. Mark that here. Sodium chloride on electrolysis break down to Na plus Cl minus at cathode. Na plus electron give rise to Na, that is known as a primary change, get deposited and at anode Cl minus electron give rise to Cl, that is known as a primary change, and the Cl plus Cl give rise to Cl2, that is known as secondary change. So from this it is clear that sodium metal get deposited at the cathode while chlorine gas get liberated at the anode. Move to another example, that is electrolysis of aqueous solution of sodium chloride using platinum electrode. Second example is electrolysis of aqueous solution of NaCl using platinum electrode. Mark that. NaCl electrolysis give rise to Na plus Cl minus, water give rise to H plus OH minus. So mark that. Here two type of ions are there. On the basing upon the preferential discharge theory, at cathode, H plus electron give rise to H, that is known as a primary change. H plus H give rise to H2, that is known as secondary change. Similarly, at anode, two ions are there, Cl minus and OH minus. If we mark the preferential discharge theory, more deposition potential is Cl minus. So Cl minus electron give rise to Cl, that is known as a primary change. And the Cl plus Cl give rise to Cl2, that is known as secondary change. So here, during electrolysis of aqueous solution of sodium chloride using platinum electrode, hydrogen gas is liberated at the cathode while chlorine gas is liberated at the anode. Move to another type of problem. Third, that is electrolysis of aqueous solution of copper sulfate using platinum electrode. Third example, that is electrolysis of copper sulfate solution using platinum electrode, that is non-attackable electrode. Non-attackable electrode. Mark that. What do you mean by attackable electrode and non-attackable electrode? The electrode which participate in the electrolysis, that is known as attackable electrode. Those electrodes not participate in the electrolysis, that is known as non-attackable electrode. So mark that here. CuSO4 break down to on electrolysis. CO2 plus SO4 to minus, water break down to H plus OH minus. So mark that two type of cation is there. So we have to apply preferential discharge theory. On the basis upon this one, what we observe, that is copper possesses more prefer than the H plus ion according to preferential discharge theory. So add cathode, Cu2 plus 2 electron give rise to Cu, get deposited, and add anode. Mark that. Between a sulfate and a hydroxide ion possesses higher preference to deposit at the anode. OH minus electron give rise to OH, known as a primary change. 4OH give rise to H2O. 4OH give rise to H2O plus O2, that is known as secondary change. So, during electrolysis of copper sulfate solution using non-attackable electrode, at cathode copper metal get deposited, while at anode oxygen gas get liberated. Move to another type of problem, that is electrolysis of aqueous solution of copper sulfate using, next problem is electrolysis of copper sulfate solution using copper electrode, that is known as attackable electrode. Mark that. What happened here? Copper sulfate solution on electrolysis give rise to Cu2 plus SO4 minus, water give rise to H plus and OH minus. At a cathode, same reaction is there, that is called Cu2 plus 2 electron give rise to Cu and get deposited. While at anode, something different is there. At anode, so copper as the anode is attackable electrode, that is a copper electrode. What happened at anode? Copper ion loses 2 electron, move to Cu2 plus ion, and it moves to the electrolyte. Mark that. When electrolysis of copper sulfate solution using attackable electrode takes place using copper electrode, then what happened? At cathode, copper metal get deposited, while at anode, equivalent amount of copper moves to the electrolyte, moves to the solution in the form of Cu2 plus ion. Move to the next one, another type problem. That is electrolysis of molten lead bromide. Next, example 4. That is Electrolysis of molten lead bromide using graphite electrode. Electrolysis of molten lead bromide using graphite electrode. Mark that. Lead bromide breakdown to on electrolysis. Pb2 plus 2 Br minus. Add cathode. Pb2 plus 2 electron give rise to Pb. Get deposited and at anode 2 Br minus 2 electron give rise to Br2 bromine. So during electrolysis of molten lead bromide using graphite electrode, what happened? The lead get deposited at the cathode while bromine is formed at the anode. Next we discuss another one is that is the electrolysis of dilute solution of sulfuric acid. Next one is electrolysis of acidulated water. Electrolysis of acidified water. That is H2SO4 break down to 2H plus SO4 2 minus H2O give rise to H plus OH minus. So at cathode H plus electron give rise to H, that is known as a primary change, and H plus H give rise to H2, that is known as secondary change. At a node OH minus electron give rise to OH, that is known as primary change. 4 OH give rise to 2 H2O plus O2, that is known as secondary change. Hence, during electrolysis of aqueous solution of sulfuric acid or acidified water, we observe that at cathode hydrogen gas get liberated, while at anode oxygen gas get liberated. These are some applications of preferential discharge theory. Hence, in the class 1 of this chapter, that is electrochemistry, I will cover introduction part, what is electrochemistry, what is electrolyte, non-electrolyte, what is weak electrolyte, strong electrolyte, what is conductor, what is insulator, what is electrolysis, the process of electrolysis, what is preferential discharge theory, and some application of preferential discharge theory.